Welcome to lecture 6. We are studying basic electrical engineering. Today we will solve a problem related to nodal analysis. This problem has multiple resistors and two current sources, and there are three nodes in addition to the ground node. We'll write KCL equations for each of these three nodes, and we'll solve for V1 and V2 with V1, V2 and V3 with the help of MATLAB. First, let's write equation 1. Equation for node 1. Node 1 has three branches connected to it. This 4 milliampere current source. The current is coming into this 4 milliampere. This 4 milliampere current is coming into this node V1. So since this is an entering current, we'll write it as negative plus V1 minus V2 over 2k plus V1 minus V3 over 1k is equal to 0. This is an equation for node number 1. This minus 4 milliampere current is an entering current, therefore we have written it as negative. These two currents, the direction, we don't know the directions, therefore we have assumed them to be leaving. For node 2, we have three branches connected with node 2, this and this. We'll assume all these currents to be flowing out of V2, out of the node 2. V2 minus V1 over 2k plus V2 minus 0 over 1k plus V2 minus V3 over 4k. So now we have three variables V1, V2 and V3 and two equations. This is equal to 0. We need one more equation. So that we can solve them simultaneously to find V1, V2 and V3. For that, we'll write equation for node 3, so that we may have three equations and three variables. V3 minus V1 over 1k, the current leaving here, the current leaving leftwards is plus V3 minus V2 over 4k plus this current 2 milliampere is definitely leaving this node, therefore this is written as plus 2 milli is equal to 0. Now we have three nodes and three equations. We have three variables and three equations. We can solve them simultaneously to give them a good shape. I have done some rearrangement in the nodes, and finally we come up with these three equations. 3v1 minus v2 minus 2v3 is equal to 8. This is the rearranged equation for node 1. The rearranged equation for node 2 is minus 2v1 plus 7v2 minus v3 is equal to 0. And the equation for node 3, once rearranged, looks like minus 3v1 minus v2 plus 4v3 is equal to 0. We have these three equations and three variables. Now we can take help from MATLAB to solve for v1, v2 and v3. First we have to write them in the form of a matrix. We can convert these three equations in matrices. We have already studied in elementary schools. How can we write a matrix from these three equations? 3, minus 1, minus 2, taking their coefficients, plus 7, minus 1, minus 3, minus 1, 4. The variables v1, v2 and v3 is equal to the constants. 8, 0, this is minus 8. 8, 0, minus 8. So we can write it as A matrix, as V matrix, or this as B matrix. So we have this A, V and B matrix, and V matrix is unknown. So V can be written as multiplying both sides with A inverse times V. So in MATLAB, we can enter, using MATLAB, we can enter a matrix like this. A is entering A matrix 3 minus 1 minus 2 semicolon. Semicolon means go to the next line, the next row. Minus 2, 7, minus 1 semicolon 3 minus 1 4. In MATLAB, we can enter the V matrix, which is 8, 0, and minus 8, like this: 8, semicolon 0, semicolon minus 8. And V matrix can be obtained containing all the values as I and V of A times V, inverse of A times V. This is how we can straight away calculate the three voltages V1. Since V is a vector containing V1, V2, and V3, this V will contain all three voltages, all three required voltages, V1, V2, and V3, once solved using this equation. In the next lecture, lecture number 7, we'll solve another problem related to nodal analysis involving dependent sources. Thank you.